Hello everybody. Today I'll be proving that the square root of 2 is irrational. So to prove that this theorem is true, I'll use a method of proof known as proof by contradiction, which basically involves assuming the logically opposite statement and then proving that that statement is actually false, and so the original statement or the theorem is true. So in this scenario, we will assume that the square root of 2 is in fact not irrational, i.e. it is rational, and then show that that is false, and so that the theorem must be true. Okay, so we write proof at the top left side to indicate to the markers where we begin our proof. Okay, so I'm going to write by contradiction to allow readers to know what the method of proof we are using is. Okay, so by contradiction, suppose that the square root of 2 is rational. Okay. So by the definition of rationality, this just means that we can write the square root of 2 as a fully simplified fraction, okay? For B, where A and B are integers with no common factors except for 1. And B cannot be equal to 0 as division by 0 is obviously undefined, okay? So squaring both sides of this equation to get rid of the surd, we'll obtain sides leads to A squared is equal to 2B squared, okay? So this is just simple algebra, and we'll label this equation here, this very important equation here, as 1, okay, for simplicity. All right, so hence, by the definition of an even number, A squared is even, okay? So we can see that A squared is equal to 2 multiplied by another integer, right? Because B is even, B squared is also an integer. Sorry, B is an integer, so B squared is integer. So A squared is equal to 2 multiplied by another integer, so A squared must be even. And as A is an integer and A squared is even, we have shown that A is also even, okay? And again, by the definition of even number, we can write A is equal to 2k, where k is an integer, okay? And now we have that A is equal to 2k, right? We have this equation here, all right? And we have another equation 1, which states that A squared is equal to 2b squared. So the only appropriate thing we can do here is substitute A is equal to 2k into equation 1 and then play around with it and see what happens. Okay, so let's do that. So let's substitute into the previous equation. So substituting into the previous equation. Four k squared is equal to 2b squared. So b squared is therefore equal to 2k squared, okay? Therefore, again, by the definition of an even number, b squared is an even number, okay? And as b is also an integer, b must be an even number since b squared is an even number, okay? Hence, b is also even. So what have we just shown? We've so far shown that A is an even number and that B is an even number. But this is false because in our proof, we've assumed that the A and B are integers with no common factors, right? Over here, we have no common factors except for 1. We've shown that A and B have both common factors of 2, which is a contradiction. This cannot be true, right? This contradicts our assumption. So therefore, our original statement is false, must be false, okay? Original statement must be false. So what's our original statement? That the square root of 2 is rational, right? Is false, and I'm going to justify why it's false, even though it might seem obvious, as A, B have common factor of 2. Have common factor 2, okay? So therefore, the square root of 2 is in fact rational, okay? It's indeed irrational, sorry, okay? So this concludes the proof. We've shown that the square root of 2 is indeed irrational, which proves our theorem. And we conclude with this little box here to allow the marker to realize where the proof ends, okay? So yeah, this is the entire proof, okay? So as we can see here, we have the theorem at the very top, and then we have the proof at the top left to indicate to the marker where the proof starts. And then followed by that, we immediately have by contradiction, suppose that the square root of 2 is rational, to immediately indicate to the writer how we are going to prove, right, the statement, and also what the statement is. So we say that by contradiction enables the viewer to realize that we're using proof by contradiction here. And then suppose that square root of 2 is irrational to allow that what we are assuming, right? Allow the marker to know what we are assuming. So then we write the square root of 2 is equal to a over b, where a and b are integers with no common factor except for 1, and b does not equal to 0. And then we square both sides to obtain this algebraic identity here. And then we deduce that a squared is even. And as a squared is even, a is also even, and we can rewrite a as an even number. By definition, a is equal to 2k. And then we substitute that equation back into equation 1, because that seems like the only appropriate and really viable decision to do, because that's really our only option here. To get that 4k squared is equal to 2b squared, so that b squared is equal to 2k squared. So therefore, again, b squared is an even number, so b is also even. So we've shown that a and b are both even. Therefore, a and b must have a common factor of 2. So therefore, that is a contradiction, as we assume that a and b have a common factor, have no common factors except for 1, okay? So therefore, the square root of 2 must be in fact irrational, as it cannot be rational, okay? Thank you, and I hope this video has helped you understand proof by contradiction.